In this presentation we are going to look at digraphs and relations, and what we're going to do is look at this example here. Given that S is the set of integers 5, 6, 7, 8, 9 and 10, what we were asked to do is as follows. Let R be the relation defined on S by the following condition, such that for all x and y elements of S, x is related to y if x plus y is a multiple of 3. Draw the digraph of R and state whether or not they're reflexive, symmetric or transitive. Okay, so let's draw the digraph here first. So what I'm going to do here is I'm going to just draw 6 vertices. And so 5, 6, 7, 8, 9 and 10. Okay, now what we're going to do is for each pair of vertices we're going to add a directed edge. Now I'm just going to sort of state here, just to sort of save time, that this is necessarily a symmetric relation if x plus y equals y plus x. So it's automatically going to be symmetric. So what I'm going to do is just add one edge between each pair of vertices rather than two. And I'm just going to have 2 arrows on it instead of 1. So the first, let's start with 5. 5 plus 7, that's equal to 12. Down here, 5 plus 10 is equal to 15. So that's the first pairing we could do. 6 and 9, that would also give us 15. Now 6 plus 6 is 12. 9 plus 9 is 18. So we have those two there. 8 and 10, yep. That gives us 18. 7 and 8, that would give us 15. Now I'm pretty sure I have all of the possible combinations, the pairings of nodes there, the pairings of vertices, but no harm in double checking yourself. So what we have to do now is decide whether or not this relationship is symmetric, transitive and reflexive. Now, I've already sort of stated out at the start that it's already symmetric, so it must be symmetric. But what we're going to do now is determine whether or not it is reflexive. So, for it to be reflexive, let's just first off look at 6 and 9. So 6 is a relationship on itself. It would seem to exist here at 6 because 6 plus 6 is equal to 12. Likewise down here at 9, 9 plus 9 is equal to 18. But those are only two cases out of the possible 6 members of the set. And for the relationship to be reflexive, what would have to happen is that there would have to be each vertex would have to have a directed edge directed at itself. For example, 5 goes by an edge going from 5 to 5, like that. And so on for each of the 6 nodes, but that is not the case. So this is not reflexive. Now finally we're going to look at whether or not it is transitive. So we have a relationship here between 5 and 7, or 7 and 5. And we also have a relationship here between 7 and 8. But does for a transitive relationship to exist, necessarily that would mean that 5 and 8 would be related. And that is not the case. 5 plus 8 is equal to 13. That is not a multiple of 3. So therefore, the relationship R is not transitive just because one vertex is related to 7 doesn't, and another vertex is related to 7 doesn't mean those two vertices are related to each other. So it's not transitive. So reflexive, No. Symmetric, yes. Transitive, no. Okay. To give a few counterexamples, you could just sort of discuss like what I've done there for 5 to 7 to 8 and so on, and also this is just a question just to ask for counterexamples. Just like make a few remarks about those type of things there. All right, that ends the presentation.